welcome to The Explainer. Today, we're setting the stage for a really deep dive into the hidden and honestly often overlooked challenges of teaching mathematics online. If you're a math teacher seeking ICT support, or, just anyone passionate about digital education, you already know that moving a classroom to a computer screen isn't just a matter of turning on a webcam. There is a massive invisible barrier that educators are facing every single day. So today, we're going to unpack exactly what that struggle looks like, who it's affecting the most, and how we can actually solve it.
Let's start with Section 1, the digital math struggle, a day in the life.
Okay, let's jump right in with a quick question. Have you ever tried drawing a perfect parabola with a computer mouse? Seriously, just imagine it for a second. Think about the sheer physical and technical frustration of trying to trace smooth, precise mathematical curves without your traditional classroom tools. You've got no chalkboard, no specialized graphing paper, just a standard computer mouse or a clunky trackpad. It usually ends up looking way more like a toddler's scribble than an actual parabolic curve, right?
Now picture this. A typical teacher sits alone at a screen, wrestling with messy fractions, jagged geometry, and these incredibly clunky digital whiteboards. They're trying their absolute best to translate a highly visual and highly symbolic subject into a flat online format. If this sounds like you, or maybe someone you know, trust me, you are not alone. Translating the physical language of mathematics, the graphs, the equations, the very specific notations, into a purely digital space is a profound hurdle. But how big is this hurdle exactly, and why do some teachers struggle with totally different aspects of it?
That brings us to Section 2, Inside the Research Study, Validating the Frustration with Data.
So here is the study we're analyzing today. It was published in the Journal of Fine Arts Campus in 2022, and it's titled Effect of Mathematics Teachers' Problems in Teaching Equation, Figure, Drawing Symbols, and Use of Software on Mathematical Content Instruction. It was authored by Dirgaraj Joshi, Krishna Prasad Shamachapai, and Bishnu Kannal. And the primary objective of their research, they wanted to measure the actual effect of online teaching problems, specifically based on a teacher's educational background and their information and communication technology, or ICT training. We're keeping things grounded in hard data today. To get their answers, the researchers used a cross-sectional online survey methodology. But get this, they didn't just look at simple, boring averages. They used something called path analysis. And path analysis is brilliant because it's kind of like a giant puzzle. It helps uncover the root causes of instructional roadblocks by literally mapping out the complex relationships between specific technical problems, like, say, software issues, and the actual mathematical content being taught.
Moving on to Section 3, Who are the teachers, the survey data?
So a crucial point here is the sample size. The researchers surveyed 258 secondary-level mathematics teachers from Nepal. That gives this study a really solid, robust foundation for us to draw insights from when we talk about the daily realities of online math instruction. And when we look at their survey data regarding ICT training, it's actually pretty revealing. 72.5% of the teachers surveyed reported being trained in ICT, while 27.5% were untrained. Having this split is great because it allows us to see how prior technology training actually impacts online teaching in the real world. Furthermore, the researchers broke down the educational backgrounds of the sample. 69% of these teachers came from a formal education stream background, which means they have degrees specifically in teaching. The remaining 31% came from other backgrounds, like pure science or humanities. Keep these two stats in your back pocket, because this is where the findings get truly fascinating.
All right, Section 4, Trained versus Untrained Educators, a Fascinating Divide.
The data reveals a stark contrast. It turns out, ICT training doesn't magically eliminate all your problems as an online math teacher. It literally just shifts them. On one side, teachers who are untrained in ICT or come from a non-educational background primarily struggle with basic things like using software and drawing figures. But on the flip side, fully trained educators with formal education backgrounds have a completely different struggle. Their main issues are drawing complex mathematical symbols and teaching equations online. If you look at the study's actual path analysis model, you can see this incredibly intricate web of relationships. It maps independent variables, like problems teaching equations or drawing symbols, directly to dependent variables, which are specific math subjects like algebra, sets, geometry, and vectors. The research essentially proves that if a teacher struggles with the digital syntax of writing an equation, it directly, negatively impacts their ability to effectively teach a subject like algebra or mensuration. It's all connected. To really emphasize this key finding, let's look directly at the study's conclusion. It says problems in using software and drawing figures are main issues to teachers having non-educational background and untrained in ICT. I mean, think about subjects like geometry, vectors, or probability. Trying to draw complex spatial figures on the fly without targeted software training, that becomes a massive, almost insurmountable hurdle for these educators.
But then we have the nuance of the trained educators. The study goes on to conclude, problems in teaching equation and symbols are main issues to the teachers of educational background and trained in ICT. So even with general tech training, these teachers hit an absolute brick wall when it comes to the highly specific digital syntax required for typing out complex mathematical symbols, like union or intersection in sets, or, formatting long, complicated algebraic equations.
So what do we do about it? Section 5. Action Steps for Success. Bridging the Digital Divide.
Based on the findings, we can outline 4 macro implications for the broader education system. First, curriculum developers need to integrate subject-related software tools, things like GeoGebra or LaTeX, directly into non-education degree programs. Second, we absolutely must develop specific training programs dedicated entirely to digital symbol drawing. Third, universities need to add digital equation teaching methods right into their Bachelor and Master of Education courses. And finally, governments and educational stakeholders really have to step up and design targeted, hands-on workshops specifically for untrained teachers to get them up to speed on drawing figures and using core software.
But let's bring this down to a personal level. If you're a math teacher seeking ICT support, here are 3 highly actionable, empowering steps you can take immediately to improve your digital instruction. Step 1. Identify your specific gap. Look inward and ask yourself, are you struggling more with basic software and drawing figures, or is your hurdle typing out complex symbols and equations? Step 2. Master targeted tools. Don't try to learn every single piece of software out there. If figures are your problem, master GeoGebra. If equations are your hurdle, dedicate time to learning LaTeX. And Step 3. Advocate for subject-specific ICT training at your school. Share this data with your administration to prove that general one-size-fits-all tech training isn't enough. Math teachers need math-specific digital tools. We've seen the struggle, we've validated it with incredible data from Joshi, Chapai, and Kanal, and we've outlined the path forward for both trained and untrained educators. So I'll leave you with this provocative thought. Knowing that the tools you use directly impact the subjects you teach, how will you bridge the digital divide in your math classroom tomorrow? Thank you so much for joining us for this explainer, and we'll see you next time.